All right, so how do you actually calculate the moment of inertia? So let's just take a disk here rotating about its central axis. The mass is m, that's mass of disk. The radius from the central point to here is capital R, and this sticking out there is the axis about which it's spinning. So it's basically, it's a disk spinning about its center, something like that, except it's a solid disk. So solid disk. Now, moment of inertia, if crudely, is mr squared, the sum of all the mi r squareds. But if we do the calculus version of it, it's the integral of the differential of mass times r squared. And so this is what we're working with here. We assume uniform density. And rho is equal to mass over volume. Well, if the density is uniform, that means the same regardless of whether I take a differential or not. So know that the density is equal to dm dv. And so dm is equal to rho dv. I know that the volume of this is equal to pi r squared times the, well, actually, it depends upon the radius, so pi r squared. So if I take some point right there, some r, pi r squared times the thickness. So dv dr is equal to 2 pi r times the thickness. In other words, dv is equal to 2 pi r t dr. And so this becomes rho times 2 pi r times the thickness. And I guess I should actually put that in there, thickness, dr. So I'm going to put that into this. So I'm now integrating rho 2 pi r thickness dr times r squared. We now have a single variable here because these are all, those and that are constants. So I'm going to pull that out front. So this is rho 2 pi rho r, sorry, not r, 2 pi rho t, integral of r cubed dr, because I have an r there and an r squared there. I now have a single variable. My radius is going to go from 0 to big R. And so I have 2 pi rho t times 1/4 r to the 4th from 0 to r, which is 2 pi rho t times 1/4 big R to the 4th minus 0. Rho is big mass over the volume, so this is mass over pi big R squared, my own screen there, yeah, big R squared times the thickness. And so I have 2 pi big M pi r squared times the thickness times 1/4 r to the 4th. That's I. And now he gets rid of some stuff. That cancels out with 2 of those. That cancels out with 2 of those. The t's cancel out. Pi's cancel out. And what I'm left with is a 1/2 mr squared. And that's the formula for a 1/2 mr squared. And that's the formula for a disk rotating about its center.